You did it late at night, on your phone, with the calculator app. $100 a month. 30 years. Whatever growth rate the internet told you to use. And a number came back that was bigger than you expected. Big enough that you looked at it for a second longer than you meant to. You wrote it down somewhere. Maybe you told someone. And then, quietly, you didn't quite believe it. Not because you thought the calculator was broken, because a number that large, out of money that small, felt like it had a catch in it somewhere. It does. 3 of them. And none of the 3 is the one you are bracing for. The catch is not that the math is wrong. The math is fine. The catch is that the answer you got depends almost entirely on one thing you were never asked to choose. Change that one thing, leave everything else identical, and the same $100 a month gives you a different answer. Not a slightly different answer. $105,000 different. Here is the part that is not your fault. Take 2 people, give them the identical question, $100 a month every month for 30 years. What is it worth at the end? The first one runs it and gets about $122,000. The second one runs it and gets about $227,000. Same contributions, same 30 years, same market. Neither of them made an arithmetic mistake. I checked both. They are both correct. One of them used 7%, the other used 10%. That is the whole difference. One number typed into a box, and the answer nearly doubles. And here is the part that matters more than the gap itself. Neither of those rates is wrong either. They are not disagreeing about the market. They are describing the same market in 2 different units. 10% is what the screen will say. 7% is what it will buy. And almost nobody tells you which one they handed you. Think about measuring something that is growing. A tree, say. You measure it every year and write the height on the wall. Now suppose the ruler is shrinking. Slowly. 2 or 3% a year. Not enough to notice in any single year. The tree really is growing. That part is true. But the number on the wall is growing for 2 reasons at once, and only one of them is the tree. Dollars are that ruler. A dollar is a unit of measurement that gets a little shorter every year, on purpose, by design. So when you project a balance 40 years forward, you get a very large number, and that number is measuring 2 things at the same time. How much the money actually grew, and how much shorter the ruler got. The rest of this is just separating those 2, carefully, one at a time. Start with the rate, because everything downstream depends on it. Over the long run, American stocks have returned about 10% a year, with dividends put back in. That figure comes from a data set that runs from 1928 all the way to last year. It is as close to a real number as this subject gets. But that 10% is a nominal figure. Nominal means counted in dollars, without asking what the dollars are worth. Measured the other way, after inflation, that same century of returns comes out around 6.5 to 7%. So both people were quoting the same data set. One quoted the ruler, one quoted the tree. And that is why the answers came out $105,000 apart on identical inputs. Now, which one do you want? That depends entirely on what you are going to do with the answer. If you want to know what the account statement will say in 30 years, use the 10. If you want to know what you could actually walk into a shop and buy with it, use the 7. Most people running these numbers want the second thing and are handed the first. That is not a scam. It is a units problem. It is the same mistake as measuring a room in feet and buying carpet in meters. Nobody is lying. The number is just not answering the question you asked. So let us ask the question properly. Take the biggest version of this you are likely to see. $100 a month held for 40 years at that 10%. You put in $48,000 of your own money, and the projection comes back at about $636,000. That is a real calculation. It is not inflated, and it is not a trick. It is also not what you will be able to spend, because that $636,000 is measured with the ruler as it will be in 40 years, not the ruler you are holding today. Bring it back to today's money, using the long-run inflation rate that is already baked into those historical returns, and $636,000 becomes about $219,000. Sit with that for a second. Because it is the single most useful number in this video. 2/3 of that headline was never growth at all. 2/3 of it was the ruler getting shorter. And it is not a small effect that only shows up at the end. At 10 years in, about a quarter of the balance is ruler. At 20 years, it is about 2/5. At 30 years, it crosses half. By 40, it is 2/3 and still climbing. The longer the projection, the more of it is measurement rather than money. Which is exactly backwards from how these numbers get used, because the long projections are the ones people quote. There is a third catch, and this is the one almost nobody runs. Every one of these calculations holds your contribution flat. $100 a month in year 1, $100 a month in year 40. The same 100 every month for 480 months. But the ruler is shrinking on that side of the equation too. Your last $100 contribution, 40 years out, is worth about $35 in today's money. You did not reduce it, you held it perfectly steady. That is the point. Holding a number steady while the unit shrinks is a quiet cut, taken every year, that never appears anywhere as a decision. So what happens if you do the other thing? If the 100 rises a little each year, just enough to stay the same size in real terms, over 40 years you would put in about $84,000 of your own money instead of $48. And you would end with roughly $284,000 in today's money against $219. $65,000 more in money you can actually spend. That is not a hack, and it is not a strategy. It is just what happens when you stop letting the unit do the deciding. And notice how ordinary the change is. It is the difference between a habit you set once and forgot and a habit you looked at again. So now let us put all three catches back in and see what is left. Not the headline. The headline is gone. What is left is $48,000 of your own money, put in 100 at a time, turning into about $219,000 you could actually spend. That is still more than 4 times what you put in real, honest, groceries and rent money, after the ruler has been accounted for. And I want to be exact about what this video did and did not do. It did not take anything away from you. The arithmetic was always this. It only changed which number you were looking at. There are 2 things it still leaves out, and they both cut the same direction: fees and tax. Neither is in any of these figures, including mine. Which is a good reminder that a projection is a description of an assumption, not a description of the future. It tells you what would happen if a set of chosen numbers held for 40 years, and nothing holds for 40 years. The tree was real the whole time. That was never the thing in question. What changed is that you stopped reading the marks on the wall as if the ruler had stayed the same length, and once you have seen that, you cannot really unsee it. Every projection you meet from here has a unit hiding inside it, and now you know to ask which one. That question is worth more than any single number this video could have given you. If you want the rest of the money system explained the same way, in plain arithmetic with the assumptions showing, there is a free guide linked below. 37 ways money quietly leaks out of an ordinary month, and what each one actually costs.